This video is for the XCEL Maths class, coordinate geometry questions. Looking at 2024 first. AB is a line segment. Let's just draw this line segment, AB. C divides the line segment internally in a ratio 1 to 3. So we can put the point C on. Approximately 1 to 3 here, this ratio of 1 to 3. A is the point 113. Fill in your information as you go. C is the point 611. And you're asked to find B. So it should be straightforward enough. These transformations, 1 to 6 is a jump of 5. And that's one jump in the ratio 1 to 3. So 3 jumps, 5 by 3. We need to add 15 onto 6. 6 plus 15 is 21. That's the B, the X value for B. And then 13 to 11, we're going down minus 2, which is one jump. 3 jumps will be minus 6. So we need to say 11 minus another 6 will be 5. So 21, 5 is the point B. Second part of this question is perpendicular distance from a point to a line. So the absolute value of AX, there's a 1 in the formula, plus BY, 1 plus C, all over the square root of A squared plus B squared. You're not expected to remember it off by heart, but it does help if you can. So we need to rearrange the formula for the equation of a line. 4 over 3x would be minus 1y, put the number in front, and then minus 11 will be equal to 0. Our A value is 4 over 3. Our B value, the coefficient of y, is minus 1, and our C value is minus 11. And then our point we have is 5 minus 2, so we have x is equal to 5, or x1, and y1 is equal to minus 2. So take your time putting it into the formula, check it on a calculator twice. So we're going to get 4 over 3. 4 over 3 times 5 for x, minus 1 times minus 2 for y, and then we have our minus 11, just move it up a bit, all over the square root of 4 over 3 to be squared plus 1 squared. So maybe do the top on its own and then the bottom on its own. And on the calculator, the top is giving me minus 7, which is why we're using absolute value. You can't get negative distance. The bottom is giving me 5. And there's 3's in there, will be minus 7 over 3 over 5 over 3. And that's going to give an absolute value of 7 over 5, which is 1.4 units for this question. Area of a triangle is this question, so we know we need to move one of the vertices to 0, 0, so this one's already at 0, so no change for x, and for y we're going down 11, so apply the same to 4, 6, so 4, 6, no change, will become 4, and 6 minus 11 is minus 5. If we apply it to minus 3, minus 1, no change, minus 3, and minus 1 minus 11 is minus 12. And the way we teach it is this one by this one, this one by this one, and we get half the absolute value. So it's the loops, 4 by minus 12, minus sign in the middle, and the other loop is minus 5 and minus 3. So we're going to get half, minus 48, minus 15, half of the absolute value of minus 63, 31.5 units squared for the area in part 1. Part 2, midpoint. If we go back to our juniors there to get midpoint, we line them up, minus 1k, 5 and L. What we do is we add together and divide by 2. So adding these together, we're going to get 5 minus 1, which I could just write as 4. And we're going to get k plus L, just showing you that we're just going to write them by adding them, and then dividing this by 2, we're going to get 2 and k plus L over 2. And that's what we're asked to show the midpoint is. Hard to believe it's a leaving cert question, but be prepared. Part 2, we're told the perpendicular bisector of AB, or the equation of it, is this guy. So if this is AB, the perpendicular bisector goes through the midpoint, creating right angles. So we have perpendicular slopes for this question. So immediately we'll get the slope of this one, writing in the form y is equal to mx plus c. The coefficient of x will be the slope. 2y is equal to minus 3x plus 14. So y is equal to minus 3x over 2 plus 14 over 2, or you could write plus 7. So the slope of the perpendicular bisector is minus 3 over 2. So the perpendicular slope is equal to 2 over 3. So I have the slope of the line that contains this point. Two and k plus L over 2. So the point 2 and k plus L over 2. And the slope of 2 over 3 could give us the equation of this line in terms of k and L. So y minus y1 equals m times x minus x1. So finding the equation of the line, we're going to get y minus k plus L over 2 is equal to 2 times x minus 2. And I'm just going to pause that there for 1 second, maybe take this approach. We have 2 points here. So the slope of AB, if we do y2 minus y1 over x2 minus x1, we'll get an equation in L and k. So let's write out L. If we do y2 minus y1, we're going to get L minus k over 5 minus minus 1 is equal to the new slope that we got, that was 2 over 3. So we're going to get 3L minus 3k is equal to 12, or L minus k is equal to 4. And I think this is a better approach, because looking down here, we're going to have k plus L and y and x in this one. So sometimes you can go down, take one approach, and maybe see straight away that it's not right. So we need another equation that we can get L plus k in. And if we take this equation, we know that the midpoint is on it. And the midpoint was this 2k plus L over 2 up here. So if we plug this point in, 3x will be 2 plus 2 times k plus L over 2 minus 14 is equal to 0. If we simplify this, we're going to get 6 plus the 2's cancel. So we get k plus L minus 14 is equal to 0. So k plus L, we're bringing over minus 8 will be plus 8. And from up here we have L minus k, or minus k plus L is equal to 4. So 2L is equal to 12. L will be 6. So k with L plus k being 8 will be equal to 2. So probably a better approach, but maybe try and finish off this one. You can do it this way as well, but it just takes it a little bit longer. In 2022, we're given A and B being the end points of the line segment AB. So I'm just going to sketch it. AB, we've seen a question like this already. We were given one of the internal points. We were looking for the end point. So AB, we have 8 minus 4 and B minus 1, 3. So the x jump here, 8 down to minus 1, we're going down 9. And y goes from minus 4 to 3, we're going up 7. And the jumps here are 4 and 1. So it's 5 jumps altogether, 4 plus 1. So one jump we need to divide by 5. So minus 9 over 5 would be one jump, and 7 over 5 would be one jump. So we want it in the ratio 4 to 1. We could start with the 4. We could actually just go backwards from the 1. So this is one jump back from B. So B, we're at the point 3, and we need to go back 7 over 5, so take away 7 over 5 from 15 over 5 and we'll get 8 over 5. And from 1 we're climbing, so we're going to need to add, we're going back up to 8, so we need to add 9 over 5 to minus 5 over 5, so that's going to give 4 over 5 from 1, so the point is going to be 9 over 5 for x, sorry, 4 over 5 for x, and what do we get, 8 over 5 for y, so let's check it from the other direction just in case. So we're at 8 and we want to make 4 jumps, so 4 jumps, we said one jump will be 9 over 5, so 4 by 9 over 5 is 36 over 5, and we're at 8, which is so 8 is actually 40 over 5, and if we take away 36 over 5 going in that direction, you'll see that we get 4 over 5, so that's correct. And then if we're at minus 4, and we want to go 4 jumps of 7 over 5, that would be 28 over 5 of a jump. We're at minus 4, which is minus 20 over 5, and if we jump 28 over 5, we will get to 8 over 5. So you can check it in both directions, no harm in an exam to do this. In part B of this question, we're given a line, has a slope of m and a point, so we're asked to find the coordinates where it cuts the y-axis. So let's get the equation of a line. Y minus y1 equals m times x minus x1. So filling the information in, our point is Q or, and we're just told m is equal to m. You can see it's in terms of m, q and r, so we get y minus or is equal to m times x minus q. So y minus or is equal to mx minus mq. And if it cuts the y-axis, it means that x is equal to 0. Therefore, we get y minus or is equal to minus mq. And if I bring minus r across, it will become plus r, and the minus mq stays there. So y is equal to r minus mq. So we have mq and r in terms of, so this is fully correct. In part C, we have the line K has a slope of minus 2. So let's sketch that minus slope. So rise over run would be minus 2 over 1. So rise 2, run 1. So this is the line K. The line J makes an angle of 30 degrees with K. Okay, so let's say this is the line J. It could be going downwards as well. That's why it's one possible value. There will be 2. So let's say this is 30. So this is the angle between two lines, and that brings up a memory of a formula. Angle between two lines, the tan of the angle, tan of theta, is equal to plus or minus m1 minus m2. I'm just going to double check this, over 1 plus m1 m2. So it is correct. If we call m1 minus 2 and m2, we can call m2 or just m. So subbing this in, we get the angle is 30, the tan of 30 is equal to, let's just take the plus version. So we go minus 2 minus m, I could have done it the other way around, instead of m plus 2, over 1 plus minus 2 by m. Tan of 30 is 1 over root 3, is equal to minus 2 minus m over 1 minus 2m. Cross multiply, and I'll come over here, we'll get 1 minus 2m is equal to minus 2 root 3 minus root 3m. So I'm going to get 1 plus 2 root 3 is equal to 2m minus root 3m. So if we factor out m, we'll get 2 minus root 3 on the right and 1 plus 2 root 3 on the left. Can this be done any quicker? I feel like I'm making a mess of it. Please tell me it can be done quicker. 1 plus 2 root 3 over 2 minus root 3 is equal to m, and we don't like thirds on the bottom, so we could soon tidy this up. What does the calculator give? You try it on a calculator while I'm multiplying by 2 plus root 3 over 2 plus root 3 to get rid of the third on the bottom. So on top, I'm going to get 2 plus root 3 plus 4 root 3 plus 6, 2 root 3 by root 3. On the bottom, I'm going to get 4 plus 2 root 3 minus 2 root 3 cancel, so I'm going to get 4 minus 3. So I'm going to get 8 plus 5 root 3. I hope that's the correct answer, and you got it before me on a calculator from this point here. So that's one possible answer for the slope insert form of the other line. This question is more algebra based, but it's in here in your workbook, so I'll do it anyway in case you have attempted it. We want to find the points of intersection, so x from the first equation will be equal to 3y plus 1. So then sub in 3 doesn't want to come up, 3y plus 1 to be squared plus 4y squared is equal to 1. You get 9y squared plus 6y plus 1 plus 4y squared equals 1. The ones cancel. We're going to get 13y squared plus 6y is equal to 0. Factor out your y to get y by 13y plus 6 is equal to 0. So y is equal to 0 with the first bracket, and with the second bracket y is equal to change the sign 6 over 13. So we solve for y, so y is equal to 0 from this equation. If y is equal to 0, we can see that x is equal to 1. So we have the point 1, 0. And we also have y is equal to minus 6 over 13. X will be equal to minus 6 over 13 plus 13 over 13, 1. So x will be equal to, I'm just saying I didn't multiply the 6 by 3, it's 3y, just be careful when you're subbing in, 3y plus 1, so 3 sixes are 18, so minus 18 over 13 plus 13 over 13 to give minus 5 over 13, minus 5 over 13, and minus 6 over 13 is the other point of intersection. Normally we get some sort of fractions that will challenge us within these questions. In 2022, the third, you were given the equation of a line and you were asked to sub in this point, show that for all values of k, the point P lies on L. So we have x is equal to k and we have y is equal to k plus 8 over 2. So we sub it in, x minus 2y will have to be equal to minus 8. So subbing in k minus twice k plus 8 over 2 equals minus 8. We'll get k, and these twos will cancel. We get k minus 8 equals minus 8. So the k's will cancel, leaving minus 8 equals 8. Therefore, and then repeat, the point K, P lies on L. Another line passes through P at this point and the point A. Find the slope of AP in terms of K, so just write our points down. We have K and K plus 8 over 2. And we have minus 1, 1. So the slope is just a change in y, y2 minus y1 over x2 minus x1, depending on the order you go, it doesn't really matter. So we'll start with this 1 being y2, so we're going to get, well actually it might be easier to start with a fraction, k plus 8 over 2, so k plus 8 over 2 minus 1, that will be the top part of the slope, and then we're going to get k minus 1 for the bottom. If we tidy this up, we'll end up with k plus 8 minus 2 over 2 on top and k plus 1 on the bottom, which is going to give k plus 6 over 2 over k plus 1, which is like an algebraic fraction. So turn it upside down and multiply, we're going to get k plus 6 over 2 times 1 over k plus 1, which will tidy up to be k plus 6 over 2k plus 2. The point B is at 3, 3. Find the value of k such the angle BAP is equal to 90 degrees. So let's just do a sketch of this. So this is going to bring in our slopes. So we have B, A, and P. Just to try and find them, we have A is minus 1, 1. If we do a sketch of it here, let's say minus 1, 1. A is going to be here. B is the point 3, 3. So out 3 up 3 approximately here. So there's A and B. Maybe change the color so you can actually see what we're doing. A and B approximately here and here. And we're asked to show that BAP. So the BAP is 90 degrees. So it could be coming down in this direction. Or it could be going off in this direction. So we need to get the product of these slopes. M1 by M2 is equal to minus 1 if the angle is 90 degrees. So we have the slope of AP in terms of K down here. So we just need the slope of AB, slope of the line segment AB. Just be careful, write the points down again. We have 1, minus 1, 1. Just double check, minus 1, 1 up here. We have 3, 3. The change in y, m is equal to, we can see this line here, it's positive slope, so you could create your right angle triangle if you wanted. The run between x minus 1 and minus 3, the run is 4, and the rise you can see is 2, so the slope is 2 over 4, which is 1 over 2. So 1 over 2 multiplied by k plus 6 over 2k plus 2 has to be equal to minus 1. So k plus 6 over 4k plus 4 equals minus 1, meaning that k plus 6 would be equal to minus 4k minus 4. Bringing minus 4k to the left, we'll get k plus 4k equals, bringing a plus 6 across, we're going to get minus 4 minus 6. So 5k would be equal to minus 10. So k will be equal to minus 10 over 5 or minus 2 for the last part of this question. Here we have the second area of a triangle question. So you can see when you practice a lot of the exam questions, you'll see the repetition. I'm just going to move the first one here to 0, 0. So we're adding 2 to x and we're taking away 5 from y. So we do the same to 4, 11. We will get add 2 to get 6 and take away 5 to get 6. And if we do the same to 7, 5, we're going to get 9. If we add 2 to 7 and take away 5 from minus 5, we're going to get minus 10. So this is the pattern we used before. We find the loops that go together, and it's going to be half the absolute value of the outside loop, 6 by minus 10, minus the inside loop, which is 6 by 9. And we're going to get half of minus 60, minus 6 nines are 54. So that will be half the absolute value of minus 114, which is 57 units squared, or squared units. In this question, we're asked to find the perpendicular distance from A to BC. So we have the point A, and potentially we have the line BC over here. So let's have a look at what happens in this question. We have A, so we need the equation of BC. So let's just plot B and C to see is a positive or negative slope. So we have 6 minus 12, so 6 out 6 and down 12 approximately here for B. And then C is minus 4, 3, so minus 4, 3 will be up here, so it's definitely a negative slope. Let's look at our rise and run to get the slope here of BC. The run is from 6 to minus 4, or minus 4 to 6 going in this direction, that will be 10. And then the rise, minus 12 to 3, so minus 12 up to 3 will be 15. So the slope is negative rise over run, 15 over 10, which is negative 3 over 2. And we'll take the point minus 4 minus 3 to sub into the equation, minus 4 plus 3, excuse me. And then we write down y minus y1 again equals m times x minus x1. So y minus 3 is equal to minus 3 over 2 times x minus minus 4. So we're going to get 2y minus 6 is equal to minus 3x minus 12. So bringing it all to the same side of the equal sign, 3x plus 2y minus 6 plus 12 will be plus 6 equals 0. So now I have to find the perpendicular distance from the point A, which is 2 minus 6. 2 minus 6 is the point A. And my A is equal to 3, my B is equal to 2, and my C is equal to 6. For the absolute value of A, x1 plus B, y1 plus C over the square root of A squared plus B squared. Let's see what this gives. We're going to get 3 by 2, and we're going to get plus 2 by minus 6. We're going to get plus 6 for A, x1 plus B, y1 plus C over the square root of 3 squared plus 2 squared. That's going to be 6 plus 6. That's 12 minus 12. So that's going to give a 0 on top over root 13. So the perpendicular distance is 0. And we're asked to comment. I think we're asked to comment on it. Comment on the relationship. Well, A would have to be on the line somewhere. So collinear. I think there might be two L's in collinear. Collinear, these 3 points is what they're looking for in this question. So in this question, we're back to angle between two lines. So the diagram below, the equation of A, this line here is given. And the acute angle that it makes with the other line is theta. And line B makes an angle of 60. We're asked to find the value of theta, so angle between two lines definitely. What do we know about this 60 degrees? Well, 60 degrees here, if we have a 60 degree angle, we can say the tan of 60 is equal to O over A, which is this guy over this guy, which is also the slope. So the tan of 60 is equal to M of the line, tan of the angle that it creates with positive density x-axis here will give us the slope of this line in this case. So the tan of 60 is root 3. And if we rearrange 2y will be equal to x plus 1. So y will be equal to x over 2 plus a half. So we have 1 over 2 here. So the m of this one is 1 over 2. So the angle between the two lines, tan of theta, is equal to plus or minus m1 minus m2 over 1 plus m1 m2. So we should be able to get a value for the tan of theta and then get the inverse of it to get the angle. So let's sub this in, see what we get. So the tan of theta will be equal to plus or minus, I'll just probably do one version of it. We get m1 root 3 minus a half over 1 plus root 3 times a half, but that would be root 3 over 2. I'm just going to type this into a calculator, and it's giving me minus 8 plus 5 root 3 for the tan of theta. Be plus or minus this, so theta, I'll get the smaller angle, 33.435 degrees when I do the inverse tan of minus 8 plus 5 root 3. 33.435 degrees. I'll correct the 3 decimals, so that's it, corrected 3 decimal places. So just angle between two lines again. You can see repetition happening throughout this video. In this question, we're back to slopes again, given 2 points with unknown coefficients or unknown variables. So the coordinates of 2 points A and B are 4, minus 1 and 7t. We have this line perpendicular to AB, find t. So let's get the slope of this one first. 4y would be equal to 3x minus 12. You might see straight away that the slope is going to be 3 over 4. Perpendicular slope is equal to minus 4 over 3. So t minus 1, doing y2 minus 1, y1 over 7 minus 4 is equal to minus 4 over 3. So we should be able to solve for this quickly. 3t plus 3 is equal to minus 4 by, this is going to give 3, so minus 12. 3t will be 15, sorry, minus 15, so t will be minus 5. In part 2, we're asked to find the distance, so they mean perpendicular distance in terms of k between, well, not necessarily perpendicular distance, between 10k and L1. It doesn't state, it says distance, so I presume perpendicular distance. A is equal to 3 on L1, B is equal to minus 4, C is equal to minus 12, and we have X is equal to 10 and Y is equal to K. So AX1, 3 by 10, plus the absolute value of B, which is minus 4 by Y, minus 4K. I'll just get rid of the plus C, which is minus 12, all over the square root of 3 squared plus 4 squared, or minus 4 squared, but be careful if you don't put the bracket around the minus 4. So we're going to get 18 minus 4k on top, and we're going to get 5 on the bottom. And it tells us in part C, this point P 10k is a bisector of the angles between this line L1 and L2. It's a bisector of the angle. So if it bisects the angle, let's say P is here, it bisects the angle, it means the perpendicular distance to that line and that line will be the same as what they're looking for here if it perpendicularly divides the angle. So we just need to do perpendicular distance again to AX1, so 10 by 5 this time, plus K by 12, 12k, plus C, which is minus 20, all over the square root of 5 squared plus 12 squared, which is equal to 13. So possible values of k, so let's simplify it down. 50 minus 20, 30 plus 12k over 13 will be equal to the positive version of above, 18 minus 4k over 5, or 30 plus 12k over 5 will be equal to the negative version of the top, would be, so we'd have minus 18 plus 4k over 5. Now the first one over 5 should be 13. So we're going to get 150 plus 60k is equal to 30 and 18 is 180 and 54, 234 minus 52k. So we're going to get 60 plus 52k, so that will be 112k equals 234 minus 150 would be 84. K is equal to 84 over 112. That's equal to 3 over 4. 28 goes into both. And on this side, we'll get 150 plus 60k will be equal to minus 234 minus 52k. Sorry, plus 52k, the opposite way around. So we're going to get 60 minus the 52k, so 8k equals minus 234 minus 150 minus 384. So k will be equal to minus 384 over 8, and that would be 50, it was 400, so 2 less, minus 48 are the two values for k in this question. And the last part is just if k is greater than 0, find the distance from P to L1. So greater than 0 is 3 over 4. Sub it into whatever's easiest. 18 minus 4k over 5. 18 minus 4 by 3 over 4 divided by 5 will be 15 over 5, which is equal to 3 units. To conclude this video.